Okay, so this video is going to show you how to use Excel to do some data processing, to do some graphing with error bars, and to deal with outliers. So as you can see here in the graph, I am pretending that my independent variable is the angle of a ramp, and I've got data, made up data here for three different trials. And the three different trials are acceleration values that I would have gotten from something like Capstone. So the first thing I'm going to do is calculate an average. You can see that I hit the equal sign and started typing the word average, and then I went and highlighted the three boxes that I wanted to average. Once I've done that, I can drag it down and calculate the average for all of my different treatments. I can adjust decimal points to make them consistent. And then I also want to calculate the half range uncertainty. To do that, we're doing the max value minus the minimum value divided by 2. So I decided to have Excel do that for me. So I click equals, and then I start to write the word maximum. When I do that, I can click the max function. I can highlight the three boxes for my three trials and hit enter, and it will pick out the highest one. I repeat that with equals min. Highlight the three boxes, it'll pick out the lowest value. So now Excel has identified for me the highest value and the lowest value in my repeated trials. I drag it down so it does that for all of my treatments. And then to do half range, I'm going to do max minus min divided by 2. So I pick that max box minus the min box and make sure it's in parentheses because order of operations, I need to do this subtraction first. And then I do \2 to divide it by 2, and I drag to get half range uncertainty for all of them. Now I want to create a graph. So I'm just going to have the values get copied down here. The way I do that is just I click an equal sign. Well, right now I'm reminding you that what I want to be on the X will be on the left, what I want to be on the right will be, or what I want to be on the Y will be on the right, and my error bars I put nearby just to remember what they go with. Now I click equals, and then I highlight a box. You'll see me do this here. I highlight that average box, and I hit enter, and then I drag it down, and so it's copying whatever values are in the average values up above. And the benefit of that is that if I make a change later, it will immediately change the average value up above, but it will also change it down below, and I won't forget to make the changes. So I'm just repeating that again, and now I have my independent variable for my X, my average values for my Y, and I have my half range uncertainties ready for my error bars. To graph them, I go up and I go to the insert button. I think that's a little off your screen, sorry about that. And then I want to pick that graph that has the dots. That is a scatter graph. That's the kind of graph that we should be using here when we have variables that are changing quantitatively, independent variables changing quantitatively, like an angle. Now I can add labels like titles and axes labels by going to the quick layout. That gives me some options. I can go in there and edit them. Or I can also go to add chart element, and I can add axes titles, chart titles, etc. Now I'm going to want to add error bars, and I'm going to want to add a trend line. So here I'm going to add error bars. I'm going to more error bar options. Remember I went to that add chart element box. And right now it's giving me both horizontal and vertical error bars. I don't want horizontal error bars. In this one, I'm just looking at the variation in my dependent variable in the acceleration trials. So I'm going to get rid of the horizontal ones just by clicking on them and clicking delete. So I want to now adjust the vertical ones. So I click on them first, and then over in this format error bars, I'm going to go to the three bars. And then if I go down below, I'll see that right now all of them have a value of 1. I don't want that. I want it to represent that half range uncertainty. So I'm going to customize it. When you go down to custom, I'm going to specify the values. So I need to tell it what I want the plus and the minus to be. So I'm going to click on the white box at the right in just a moment, and then I will go click on all of my uncertainty values. So highlight all of them, click enter, and then I will repeat that, click the white box again on the negatives and highlight them and click enter. Then click OK, and it will automatically adjust them to the values that are in those boxes. And you should double check and make sure it's been done properly. You can see that the value in the second box is the biggest, and that also is the biggest error bar by far. You can see the last one is kind of the second biggest, and that's the second biggest error bar. So just making sure that you have done this correctly, making sure that the error bars make sense. Okay, now what I also want to do is add a trend line. So I'm going to click on my data points, and if you do control click, you should get the option of adding a trend line. See it there? But you can also go back to the add chart element. Now you'll only see that if you click up above. There's a tab called chart design. Right now you can't see it, but if I eventually here will click on chart design, now you can see that add chart element at the top left. And so from there I can also pick trend line. And it looks like a linear trend, so it kind of automatically picks the linear trend for me anyway, so I'll click that. Now I want to do things with my trend line, so I'm going to click on it, make sure I'm on those bars again at the top right, and I want to go down and I want to make sure that I display the equation on the chart. That is the equation of that line, and I click on it again, and I also want to click on that r squared value. Both of those have some nice information for me. The slope of my trend line tells me quantitatively with a number the relationship between my y and my x, so between my dependent and my independent. It's basically the answer to my research question. My research question is, how does the independent variable affect the dependent variable? Well, that number tells me exactly what my data suggests the answer is to that question. And the r squared value gives me a sense of how closely the line fits my data. If it's a value of 1, that means the line goes through all of my data points, so it's a very good fit for my data. In this case, it's 0.98, so that's a pretty good fit for my data. Okay, so there's our graph. Let's say that we see that, and I'm just pointing out about the labels and adding units and a good title, those types of things. Okay, but let's say that we see that one of our data points doesn't fit the trend line very well, like that second data point, the 4-degree trial. So what I might want to do, I'm still going to have this graph in my lab report, but maybe I want to add another graph where I suggest that there's a data point that is an outlier. And I can see that first trial at 1.88 is really very different from the next two trials. It's actually higher than most of the values in my 6-degree treatment. So what I want to do is I want to see what would my graph look like if I don't include that 1.88 point. If I say, I think something went wrong in that trial, so I'm going to take it out of the data and see what happens. So I've highlighted it in yellow, and I can't like just pretend it never happened, but I am going to see what happens if I take it out of my average calculations. So I'm cutting it out, and I'm keeping track of it down here in yellow, and you see that because of the way I set up the spreadsheet, it automatically adjusted my average values both at the top and down below. It also adjusted my uncertainty values because it changed what the max value was. So now I'm going to make a new graph. Once again, I'm going to go to Insert Scatter Graph, and you can see it looks really perfectly linear now. I'm going to add a trend line again. That was a mistake. Data labels, but no big deal, we'll erase them later. We're going to add that linear trend line again. We're going to display the equation and the r squared value and pull them off to the side. Now again, I don't have labels yet on this graph. It's a good idea to do labels first because you'll watch what happens here. When I try to add the title and the axes labels now, it will erase my trend line. And it's not a big deal, you just have to add it again, but if you don't want to have to add it again, then add the labels first. Now click on the data points and add the trend line. Okay, now I want to add the outlier point. So it's over there, and I want it to be separate from my original data points, so I don't want it to affect the trend line. So I'm going to right click, control click, and I'll get the option of select data. When I do that, it's going to show this first box. That's my original data. I don't need to do anything to that. I'm going to click on the plus sign down below that box, and that's going to add a second series of data, series 2. I'm going to name this outlier because I want it to show an outlier point. And then I'm going to tell it what the outlier point is. So I'm going to go tell it where the x value is. And you could, I guess, type them in manually, but I like to have it on the cells. So I click on the white box and hit enter. I click on the y value for that outlier point and I click enter. And now I click OK. And look at that. On my graph, there is now an orange dot on the side. It says that's an outlier point. And I can see that that point was really quite far off from the rest of my data. And so I would add error bars and titles and things to finish off this graph, but now I have this point, and in my conclusion I'm going to want to address why I think that point is an outlier and perhaps what maybe caused that point to be an outlier. So I should try to explain an outlier if I'm going to take all the time to do this. So if you decide to do this second graph, this is in addition to your first graph, and make sure it's labeled clearly so I understand the point of the second graph showing the outlier. You don't need to necessarily do a second graph. If you don't think you have any outlier data points, then by all means do not do this. This is only if you think you have a trial where something clearly was off and you want to see what the data would look like without that point, but you don't want to just completely ignore it. And then you can have a graph that has an outlier point clearly separate from the rest of your data.